All right, so guys, we're just going to do a very small part of this today. I'm not going to overwhelm you with a whole lot. I'm hopeful a lot of you have learned how to do this already. Because of the princesses? All right, so again, make sure you flip to day 2. I'm going out of order here. All right, so I think you have to flip to the next page, though, because day 2 is at the bottom. So go ahead and flip to the next page. For whatever reason, when I printed the highlight, it actually covered your word there instead of highlighting it for you. So it's GCF should go inside of there. So what we're going to do next, our next chapter, we're jumping to chapter 4. We are going to start with working on factoring quadratics. So I don't know how many of you have learned how to factor. Think of, I'm going to use some bad language for a minute. Think of when you FOIL something. I know, I'm sorry. Factoring is undoing that. It's like taking it back to where it started before you multiplied them together. That's what factoring is. But there's a lot of different ways to factor. So we're going to kind of start getting into all of that in this chapter. But I'm going to kind of jump. I usually wait and do this like second day, but we got some time. It's real simple, so we'll just throw it in the first day. It's just taking out a greatest common factor. That's what GCF stands for. Some of you, I think, probably remember doing this at some point. So what is the greatest common factor that goes into 6 and 8? 2. All right, we're just going to get some real basic practice to start with. 2. It's the biggest number that divides into both. What about 12 and 20? 4. 24 and 36? It's 12. 12. 12 is the biggest number that goes in there. Now, some people are going to go, oh my gosh, how do you know those numbers? Now, if you're really good with your multiplication facts, you probably kind of just look at them and you just know. If you are somebody who's terrible at multiplication facts, the one way you could do it is kind of write all your facts out. So like I know 1 and 24, right, making for 24 here. Then 2 and 12, 3 and 8. See my nice ordered list here. 4 and 6, no 5, and then if I say 6, I'm back following up my list. Okay? And then if I do 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. So pretty much what you're doing is looking at the list of all of the factors, and what is the biggest number that shows up in both lists? The biggest number, 12. All right, so that's what we're doing. If you're somebody who's like, oh my God, I have no idea how to do this, that's what you do. You write out your list of all your factors, find the biggest one in both lists. Hopefully the numbers, though, they're not too crazy. You can usually just look at them and know. All right, but then, of course, this is an algebra class. Got to have x in there, right? Got to deal with variables. So the way, I like weird ways to remember things. It's just kind of the way I work. So for me, when I think about taking out a greatest common factor, I have kids, right? I have 3 kids. So if they're all doing something together and get themselves in trouble, is it fair to take like 2 toys away from my son and 1 away from each of my daughters? They would throw a fit, right? Like, why did he would throw a fit? They wouldn't. You know, why do they only get 1 taken away and I get 2, right? He'd be upset. So what we're doing is we're trying to be fair. So when we're taking out a greatest common factor, it's like I'm taking stuff away from my kids. I want to punish them fairly. So if I'm taking 2 from my son, I better be able to take 2 from each of my daughters. Okay? So it's kind of what I'm thinking here. But I'm also, I'm a mean mom, and I want to take as much as I possibly can. I'm really not a mean mom. But you know what I mean, for the purposes of our demonstration here. So when I'm looking at 2x and 6, and I'm asking you what is the greatest factor that goes into them, like what's the most I could take? Just a 2. Can I take an x? Why not? 6 doesn't have an x. If I can't take it from all of them, I can't take it. Okay, what about 3x and 12x? 3x. 3 is the biggest number, and they both have an x, so I could take one. 8x squared and 20x. 4x. Why not 4x squared? That one doesn't have 2 of them. It's only got 1. That one's got 2. Is that making sense? If I want to take it, I have to take it the same from each of them. I got to be fair, or they're going to throw a holy fit. All right, so now let's actually factor it out. Okay, most students can usually tell me what it is, but then we kind of forget to actually take it out. See that a lot. All right, so factor out the GCF from each expression. So the greatest common factor. So what between 3x and 15, the GCF is 3. I can't take out an x because they don't both have one. It's not fair. Now, when you are factoring out a GCF, it's really like you're undistributing. It's what you're doing. So technically, I'm just dividing these by it. So what's 3x divided by 3? Just x. I got a plus. And 15 divided by 3 is 5. So what you are doing is you are, in essence, you are undistributing it. It's like I'm just undoing everything that we've always learned how to do. You're undoing it. Can you check your answer? Yeah. 3 times x is 3x. 3 times 5 is 15. It worked. It should be the same, right? It's just not changing the value. It's just changing the way it looks. All right, what about the next one? 2? Somebody always wants to tell me 4. Does 4 go into 18? No. All right, can I take an x? No? Why not? Oh, yeah. See, like my son has some, my daughter has some, but my youngest doesn't have any, so I can't take it. Yeah, you got to take it from all of them. All right, so that means I'm dividing all of these by 2. So what do I have left? 18x squared divided by 2. 8x divided by 2. 12 divided by 2. Now, this is the part of a math class that some of you should be happy with, because I always have students like, well, can I check my work? How do I check that? And there's sometimes you're like, you can't. You just got to trust you did it right. Now, can you check every one of these? Yeah. So what kills me is when people take a quiz or test over this and they hand it in, I'm like, these are all wrong. You should have knew they were wrong when you turned it in, because you could check every single problem. All right, how about the last one? What goes in all of those? Can I take an x? No. Oh, they don't have an x on the end, so I can't take an x. But 3 is the biggest number that goes into all of them. So 15x squared divided by 3. 45x divided by 3. 12 divided by 3 is 4. There we go. See, I told you today wasn't bad. It's so hard, isn't it? How many of you have learned to do this before? Okay. Unfortunately, factoring is like my most favorite thing in the world to do. I love factoring. All right, well, what about 24x to the 4th minus 8x cubed plus 32x squared? 8x cubed? All right, so he said 8x squared. Squared means 2. Why can I not take cubed? Why can't I do 3? Yeah, it's 3, and that one only has 2. I can't take out any more than they have. I have to take it from each of them. All right, so taking out an 8x squared. So that means here in the beginning, I'll write this when I'm dividing. Eventually, I will phase that out, and we'll just kind of do it without writing that down, okay? 24x to the 4th divided by 8x squared. 3x squared. Exponents are pretty easy at this point, because you're like, all right, I had 4, I took 2. I got 2 left, right? I mean, seriously, that whole I'm taking it away from you theory, it's kind of, it follows through here. So 8x cubed, I'm taking out 8x squared. What are you left with? Just an x, so minus x. 32x squared, taking out 8x squared, is just 4. Good. Now, I do want to tell you, most students, you guys did not do it, which I'm actually really happy about. Most people don't see 8. They tell me 4. Now, let me show you something. If I would take out a 4x squared, right, I can divide 4 out of these. I'd have 6x squared minus 2x plus 8. My brain stopped working for a minute. Right? And they're like, yeah, I can take out a 4x squared. I can. I'm not done. The reason how I know, look inside of here. Is there still something common? There's still a 2 common, okay? So that's how you know if you took out the largest thing, because you have to take out the biggest thing. You're a mean parent. You're taking away as much as you possibly can, all right? If you look and there's still something common, you're not done. That's considered not factored correctly. Okay, does that make sense? All right, so always just look for that. All right, 15x cubed plus 27x squared. Good. He's not using that other terminology now. 3x squared. So again, I'm taking out 3x squared from each of these. So what are we left with? Good. 5x plus 9. How do I check my answer? Just distribute it back. You should get what you started with. Uh-oh. Bless you. That the last one over there's got x's and y's. So I'm taking Matchbox cars and I'm taking stuffed animals. Whatever. Just think that's what my kids have all the time in their house. All right, so think about the number first. What comes out? 5. How many x's can I take? How many y's can I take? So if they have more variables, because I could give you some real doozies of problems, right? They have like lots of variables. You just as much as you can from each one, right? They all got to have it. All right, so what do we have left? 4, just 4x right there? Yeah, 20 divided by 5. I took 1x away, and I took all the y's they had. And then if I take a 5x from here, got confident with your terms there. Good. Questions? That's just taken out of GCF. Thought it was pretty simple little part I can kind of throw at you early here. We okay?